Great day. Welcome back to my channel. Okay, before I go teaching the basics of aquaponics and all the boring essentials of starting an aquaponic system, let me give you a tiny project for you to enjoy. Mind you, this is a scalable project, so please listen well. Because I can't buy new materials to show you how to construct this project, I will sacrifice some of my plants and a little bit of sweat to deconstruct one of my old projects. What we are deconstructing today, or trying to build today, is a wicking bed. It's not a wicker bed, or a wicked bed, it's a wicking bed. The wicking bed is not a new invention. Archaeological evidences of gardens irrigated by capillary action dates back to about 2,500 years, near the city of Old Jerusalem. In the late 1800s, wicking for plant watering can be traced to Ohio, USA in 1890s. Popular Mechanics magazine in 1909 made mention of self-watering flower box that protects plants from neglect. A patent was actually granted in the United States in 1817 for sub-irrigation planters. In the 1970s, an Australian, in the person of Colin Austin, started a series of experiments on how to save and regenerate topsoil. He then went to Africa to see if he could teach locals to grow successful crops even with periodic droughts and erratic rainfall. Colin developed a unique system called the wicking bed, which essentially harvested and stored rainwater and utilized by plants during periods of drought. The big question is, what then is a wicking bed and how does it work? Well, a wicking bed is any container divided into two parts. The bottom part being the water reservoir and the top portion, which is the cultivatable area. Wicking is the process in which water goes up against gravity towards the cultivatable area because of four factors: transpiration, adhesion, cohesion, and capillary action. So, what are the advantages of having a wicking bed? First, wicking beds are super efficient when it comes to water management, only bringing up water required by the plant and any excess water still stored in the reservoir. Second, water is not easily wasted through evaporation because the reservoir is at least 5 to 10 cm below the surface, where the sun's heat cannot reach it, and it will also not drain too deep that the roots cannot obtain it. Third, because wicking beds use the four principles: adhesion, cohesion, transpiration, and capillary action, soil on the cultivatable area is never too dry nor too wet, such that the plants themselves become the regulators of soil moisture. Okay, enough of history. Let's go start the project. First, grab a container. For our video, I used a half-cut IBC tank with a height of 18 inches. As you can see, I cleaned out the project first. Next, we need to place a drain, about 4 inches above the base of the container. For this project, I used a 2-inch male and female adapter and sealed it with black silicone. This will serve as our drain to protect the wicking bed from being waterlogged. Before doing anything else, test the drain first. Make sure it is watertight with no leaks. I usually set this, seal it, dry it for 24 hours, test it the following day for leaks before filling up the reservoir with anything. Next, we need to make a downspout. The downspout is made up of 4 parts. First, a 4-inch PVC pipe running along the whole diagonal end of the IBC tote. This pipe should have holes throughout its whole length to provide easy drainage of incoming water to the reservoir. Second, we have to wrap the entire length of the base pipe with a semi-permeable wrap. Materials that we can use are the following: a burlap sack, sako, a straw sack, sako pa din, cotton cloth, damit na gawa sa bulak, or if available, geotextile. Wala katambas to sa Tagalog. Pasensya na. Third, we attach the perforated base pipe to an appropriate sized pipe elbow. Lastly, the downspout pipe is attached to the perforated base pipe through the elbow and arranged on the IBC tank as shown. Okay, it's time again to move those muscles and fill the reservoir with filling materials. Ideal filling materials for the reservoir are the following: river pebbles, river sand, 3/4 size gravel, lava rock, and the best but not quite available in our country, vermiculite. Mind you, kindly check if your local quarry is rich with limestone, else your wicking beds will become very basic in pH. Fill up the container up to 1/2 full with filling materials. Next, we cover the top portion of the reservoir with another semi-permeable membrane. This is done to prevent soil and roots entering the reservoir. Mind you, cover the whole reservoir and be mindful to insert the semi-permeable membrane into the sides of your container to completely block root access into your reservoir. We can now fill our reservoir with water. I prefer to do this first so as to check for any leaks from the container or from the drain. An elbow and straight tube is attached to the outside drain and placed at the same height as your reservoir. In this project, I placed it lower because I usually dump my aquarium water weekly into my wicking beds. Finally, we fill up our container with cultivatable soil. My mix usually consists of 1/3 compost, 1/3 vermicast, 1/3 garden soil, or 1/4 cocoa peat, 1/4 compost, 1/4 vermicast, and 1/4 rabbit manure. Wicking beds are awesome. Here are some plants I was able to grow in our hot province. If you are scaling this build down to a smaller or bigger container, remember, half is filled with filling materials, half cultivatable soil, which is separated by a semi-permeable membrane. The base pipe can be as small as 1/5 of the size of the container or as big as 1/3 of the whole height of the container. Well, that's it for today. I will try to upgrade this plan on a lawn area in the next video. Thank you once again. Kindly like, comment, and subscribe to my channel.